Okay, audio check. 1, 2, 3. Right, sounds good. Oh, thank you, JTL. I appreciate it. So, here we are. And yesterday, we tackled the very last of our technical debt. And we made a choice, we did the thing, bit of refactor here and there, not too bad. Then we had time left over, so we started on our technical improvements, the last few before we go into final polish mode. One of the things we did was that sound now plays with our time scale, so when we're playing a playback at quad speed, the sound scales with the time. So that's good. Now it's only integer multiples allowed right now. Because anything more complicated than that would have been significantly harder, but that's fine. Dum-dum. And we did set it up so that animation and sound and EggTimer and stopwatch can say whether they use the real time or the scale time. So that was pretty good. That went smoother than I thought. So we had time left at the end. We also implemented a practice game mode so that we'd have basically you can practice one word with as many guesses as you want, just to practice. No high scores, no replays, no run. It's just a practice. Then we went ahead and added a bunch of text to the about scene. So we actually got quite a bit of work done yesterday. Good progress. And that leaves us in a state where we can add this feature. I kind of had next week planned for bonus features if we had the time, depending on the technical that we were tackling. But we clearly have the time. So I don't know how far down the sprite sheet animations road we'll get. But we are going to definitely start it today. And with that out of the way, we should be in really good shape to head into our polishing phase. So, sprite sheet animations. Basically, let's see. If you have an image, let's see if I can do this somewhat quickly. Do something like this. 2, 3, 1, 2, 3, 1, oops, 3, 1, 2, 3. Okay, seems good. If we had something like this. Okay. 1, 2, 3, 5, 6. Okay. So if we have an image, and if this is UV coordinate 0, 0, and this is UV coordinate 1, 1, we can break the whole image up into little tiny slices, which you can think of as tiles, right? So if we divide this into, what is it, six columns, each one has a UV offset of 0.1666, right? And if it's in 1, 2, 3, 6 verticals, then same thing. So basically we can say, here's how each sub-image is laid out. Okay, and I think we already have that concept in our image.txt file, where we can lay out, oh wow, we don't have any examples of it. Okay. Tools, embed, PNGs. Okay, so we do have the concept of UV tiles and UV sprites. And And I'm not sure that I understand if there's a difference. So UV tiles needs a pair of basically a number of rows and a number of columns. And I think sprites, is that exactly the same? Yeah, it kind of looks like sprites is exactly the same as tiles. So maybe we don't need a sprite specific, but basically we give it a width and a height in rows and columns, and it splits the image up into those rows and columns for us. So it does all that subdivision math for us. I'm trying to remember. So we give it a name, which is the image, then the row, and then the column. Then we give it a number, so we don't have to look it up at all. But yeah, I don't know. Oh, I think this is the difference with sprites. You just get a number. You don't get the row column differentiation. I guess that makes sense. So the idea is, go back to Scratch. So we split this up with UVs, and we can set up an animation, right? Oops. Which maybe it feeds a dot across, and then 1, 2, 3 dots, then 2 dots, then 1 dot, right? So we can play through this animation of something moving or changing by just switching which frame we're pointing to, which subsection of our image we're pointing to. So that isn't exactly rocket science. I think we've laid out everything we need, mostly. So what we're missing is a way to take a texture quad and tell it to do the sprite thing. So sprites. Sprite animation. We have a single texture. Frames are defined in UV coordinates. Our asset pipeline already gives us sprite row count, column count, abilities. Sprite frames are simply indexed. So a couple things that might happen. Well, let's just not. I think a sprite needs a little bit more information than what we're currently giving. Okay, sprite frames are simply indexed. We need to decide a frames per second. We need a texture quad. And we're only going to support texture quad right now, not like the bash texture quad or anything weird. Just a single texture quad. We need to know how many frames per second. I think sprite. So what if we have a 15? So let's hear a couple of pieces of information. Textures that go on the GPU should be powers of 2 in size. So the width has to be a power of 2 and the height has to be a power of 2. They don't have to be the same power of 2, but performance is better with powers of 2. One thing might happen is that our animation needs 15 frames. There's just no good way to get a nice square thing. So maybe we do like a 4x4 4, but then we tell it there's only 5 frames and we leave the 16th off, right? There's just nothing there. Maybe. We could potentially also, so maybe we need to do something like this where it's frame count, right? But what if I have a very small, simple animation or 2? So let's say I have 2 animations. I can embed them in the same sprite sheet. Then I just have to tell the animation itself sprite index offset and count. So I can embed as many sprite animations as I want. This also lets me do things like if you have multiple animations, like maybe you have just the progressing dot animation, right? So maybe you go 0, 1, 2, 1, 0, or maybe you go 0, 1, 2, 0, 1, 2. So maybe a repeat and loop, repeat, loop. So those are a couple of options I might think about. And then this would be a separate animation here. So maybe some state of your object determines what sprite index and offset and count to do. That's not my least favorite. And do we want sprite animations to be separate? Ooh, we are building a game without a game engine. So minimal dependencies. We're just about done with the main development effort. We did a cleanup phase last couple days. So today we're just adding sprite sheet animations, and then it's in polish phase where we're gonna actually redo the art and then tune the animations and things, make it a better user experience. So Testy calls 420 RZA, welcome. Yeah, so sprite sheets. So we're just talking about the design of our sprite sheet animation stuff. I don't know if we'll get it all done today, but we might get it all done today. Looking at the different options, doing a little design work up front. So, in my mind, this is different enough to warrant a separate animation thing. So we already have the concept of animations. Already defined somewhere. But I think a sprite animation is different enough from this that we want to do that. We want to do a sprite animation as a separate thing. So, the first thing I need is an animation sprite sheet. So, can I find one that I can use? Open game art. That's okay. Well, I'm going to download this real quick and I'll take a look at it. Okay, very cute. So there's a couple of different ways we can do sprite sheet animations. One thing, so this isn't the only way we can do this with UV coordinates. This is probably the most efficient way because you load one texture and then you're just done. So one other thing you can do is just have an array of textures that you step through. So let's just method 1, array of textures, method 2, single texture with UV tiles, frames. We're gonna call them frames. So there's two different ways we can approach this problem. So I'm not sure which way I want to go just yet. Or if we support both. We could do both, question mark. Three, support both. Let's put this in our actual design journal. Notes. So we already have an asset pipeline set up where if I give it a row count and a column count, it'll give us the UVs all calculated. And then we just get a simple index. The sprite animation, I've pretty well decided we're just going to make a separate class for that. For now, we're only going to support a single quad. Index with an offset and count. Cool options maybe for repeat or loop or do we want to ease our timing curve, our time? That's an interesting idea. And the animations don't all have to have the same frames per second. I think it's reasonable to have a same default, maybe like 30 frames per second. And then do I want to do like an image interpolation? For now, no, but it's an interesting thought experiment. Okay. So let's pop open, let's see, where's the thing? Put this over here, then I can let's see here. Let's bring up GIMP. Which can take a few seconds. So I found a free spinning coin sprite animation. Which in theory, where did I put that? I guess it was in downloads. Downloads. Wow. Oh, I haven't expanded it yet. Okay, let's extract everything. There we go. Just open them all. They're tiny. So we have a spinning coin animation. It's a classic, right? 8-bit. Not our style, but we're just developing the technology right now. So what they've got is 6 frames, and every one of these is 30 pixels. Not 32 pixels, 30 pixels. So this is one way we can do a sprite, is texture to texture to texture to texture, right? Or we can put all these in the same texture and let our UVs handle it. Or we could support both. So there's merit both ways. It lets you do different things. So I guess we'll implement it both ways. So let's whip up real quick a new image, which will be 3 by, well, I guess it'll be 4 by 2. 4 by 2 by 32. So if we went with a 32 32, but we want 4 and 2. So this will be 64 tall, oops, and 128 wide. New layer, make it a transparent layer, need our background layer. And now what we want is, we want 2 pixels over, 2 pixels down. Actually, this might not be right. Copy paste this guy. Oop, I did not want to do that. I want to copy like the whole. Okay. Alright, we're just going to try the old click and drag method. Is that inserted as a new layer? There we go. Boom, 1. Give ourselves a 1 pixel buffer. This thing there. So I guess the next one is at 33. 1, 2, 33 plus. So what we want is for the engine, our sprite sheet animation to figure out the UV coordinates automatically. So maybe we okay, so there's that. Let's go 31. 1, 2. This one. So these 1 pixel there. Oh, 1 pixel there. 2 pixels there. So let's drag some more coins on here. Um, 0.4. Two. One, two. Okay. So basically, each and every one of these coins is now given a 32 pixel area in our space. If we've laid this out right, we've got our first single texture image of a spinning coin. Let's save this one somewhere. Where am I going here? I want active projects, word sleuth. We want assets, images. This will be a test coin, which we will then export as PNG. Okay, then that same folder, we're going to dump the other as well. So let's get, what's it called? Active projects, word sleuth, assets, images. We're going to dump these coin images in there as well. Okay. With that done, we should just save and exit. Okay. So let's go to our images. We want coin1.png 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Point to the right directory, images. So that's everything we need for that animation type. The other one we need is our test coin.png, which lives in the same place. One of these days we'll have to fix our asset pipeline, but you know. But it has UV Sprite. I think we don't need anything more than that. Embed PNGs, UV type, UV definition. UV sprites. Word. What's this word? Do I remember this word? So when we write it out, what do we write? Do we ever use it? Into our UV. Okay. So I guess we do have to provide it a word. Okay. So UV sprite. Oh, that's an interesting idea. Spin. Then we set a UV sprites. We get a word. That's a key. Okay, so this actually can be a lot more fun and interesting and complicated. Good. I'm glad I thought ahead. I don't remember having thought ahead, but I did. So one thing we could do is we can say the spin animation is from frame 0. Oh, let's see here. We could say given a tiling of 2 rows and 4 columns, and we want indexes 0 to 5 inclusive. Then we could have like flip, which would be defined from 6 to 7, or something like that. So we can define each animation with a name at asset embedding time. So let me think about that for a second. That'll add some implications. We're going to have to make some changes to our asset pipeline, but I think that is the right path. So let me... I was unprepared today. I did not have my hot water heated, so I'm going to go heat up some water and think about this. We'll have to make some changes to the asset pipeline, which I think is fine. We've got the time. I set aside this week, well, I set aside through next week to add our last few bells and whistles before polish phase. So we've got time. I'm gonna think about this while I go heat up some water. So let me. Sometimes you just need a minute to think and to let it percolate in the brain. Heating up water for yerba mate. Be back soon. All right. So you think about it, I'll think about it, and I'll catch you on the flip side. Okay, we are back. Sorry about that. Usually I'm more prepared. Usually I have my hot water ready to go, but for some reason I spaced it this morning. So, I like this. Mostly. I like this mostly. So, the question is, why am I hesitating? What's keeping me from using this in any meaningful fashion? What's missing? So I'll get the image, I'll get the underscore animation name, then I'll get a whole bunch of UV values. And the index. Oh, the index for the animation, I think. So where I write it out, UV key. Maybe we just try it and see what it does. Let's just put it back the way it was, like that. Build target equals embed PNGs. That's so close to right. What? Oh, no, that should work. What? Oh, embed PNGs. Let's build this here. There we go. So one thing that would be cool is if I knew if I could just give a whole name to the sprite thing in my image store. So for our shell, we're going to go into tools bin./embed PNGs. Okay. I love that it failed to open file for reading. Test coin. Okay, so what have I done? What have I done? We need to look at what we're parsing out here. Okay, so let's see, we're going to take a word. At the end of this, we should just be able to print UV Sprite, modulus D rows by modulus D columns. Something like that. So we scanned into our word and into data at 0 and data at 1. So we should see that somewhere. Bad application. I'm not as worried about that just yet. It failed to load my PNG. Is it in test coin? .png. Did I type it wrong? Typo it? I could have typoed it. Testcoin.png. Assets images testcoin.png. So what if we don't do this for now? And just rerun it. Is it the image itself that's busted? No. So if we did UV rectangle, test from 0 to 0, 32, 32. That just works. So what we're looking at is it generates in source file or ImageWarehouse. Let's just put one in here. UV Sprite. Spin. Mm-hmm. Read or load something that it should not. All right, so something running here. We know UV rectangle works. Do we know if UV tiles works? Let's go try that. I'm pretty sure we did at one point, but I don't think we ever tested sprites. So tiles. ImageWarehouse, which we just regenerated. So it does have spin, row, column, row, column, row, column, row, column, row, column. Interesting. That's incorrect. Oh my gosh. Oh, it's not row count, column count. It's tile width, tile height. No, it's not. Is it? It actually probably is. So that's a good question. Do I want to do it by tile size or by row column tile count? Drivest, I'm doing well today. Pat, what's up? Not much. Just working away on sprite sheets today. We'll see how far we get. I mean, your voice channel on your Discord. Oh, let's see here. Discord. Yeah, that would be a boring place probably. We are. I don't even know why I have a voice channel there, other than when it's probably there by default. AK Elements is rating. Cool. Welcome back. I'll wait for the landing party to arrive. It's there by default. Yeah, I just haven't removed it. Like, the only reason it's there is because it's default. Well, nice. Cool. So we made some assumptions about our UV tiling. So if I made it 32 by 32, and it would embed things a little bit differently. Yeah. Oh. Oh, even more interesting. That is not the right number of rows or columns, so we have a math problem. But AK Elements. Hey, I'm doing good. How's it going with sprites? Oh, we just started. Like, so far, mostly done some like design talk, right? Whether we're going to do it by array of textures or a single texture with UV frames. I think we'll probably support both. But it looks like my asset pipeline is not quite up to snuff. So how is your stream today? How are things going over in probably your your physics-based rendering? You said you were pretty close last time. Recommend one texture. Yeah, I agree. I think there are times where it's easy to just slap down some textures, throw them in an array, and walk through it. But we'll probably start with the single texture. It's less texture paging in and out. It's going good. Sky rendering optimized one compute shader by a factor of 4. Nice. Nice. That's cool. So sky rendering, what's different about sky rendering? I know that the skybox is treated a little bit differently from other things, but I don't know why. Or maybe I just heard it once, but don't remember since I haven't done it. You're not using a skybox. Okay, using a technique that's called really my scattering, real physical atmosphere. Oh, okay. Well, I guess I'm not up to date on the latest modern engine techniques. I'm going to copy paste that and read on my own time. 2016, huh? Okay. Well, cool. One more thing for me to learn. Ooh, shader toy. There you go. Huh. Yeah, that's already more dynamic than any skybox I've ever seen without having to do weird atmospherics. That's pretty cool. Nice. Yeah, I'm definitely gonna have to do a little bit more reading up on that. I've decided after this project I'm working on right now, I'm gonna take off the OpenGL 3.3 chains and do some learning. I was trying to keep my scopes pretty narrow, so there's just so much to learn. So much to learn. Here's one of the official papers about it. GitHub, OpenGL version. Okay, okay. Yeah, a little light reading in my free time. Sweet. Dimensional homogeneity. Check the compile time. Cool. Nice. 2017. Well, that sounds like fun. That sounds like an exciting problem. And how's the engine coming along? I guess what's your roadmap for the engine? I'm curious. I know you did your node-based editor, you did your PBR, you're working on sky rendering. Yeah, I'll bet the physics on the paper are pretty heavy. Still, thanks for the link. Always good to have reading material. So tile size. Did I add my own to-do list? So this is my to-do list for after this project is over. Things to look at, play with. Tech use, code snippets in, that's it, pipeline. Once this guy is done, I want to add shader graphs based on the node graph yet, and then not sure yet. Probably going to start doing a game with it. Yep, if you're not building games with it, it's just a toy, right? Until you use it as a tool, you're just playing, so that's good. Do you know what kind of game you're going to do? I know. You should start with massive open world MMO first person shooter. That's what you should do. I always love new game studios. They're like, we're gonna build the great World of Warcraft killer for their first game. Yeah, exactly. I mean, it works so well for Amazon Studios, right? Okay, so we're reading it in. So what's the industry standard? Let's see here. For texture tiles. I mean, I guess I can decide it any way I want. You have an idea for a game, but it would not use any of the fancy rendering features, probably. That's a problem. Because you do want to exercise the systems. Gonna have to find a way to squeeze it in somewhere. Although, again, if they're small toy games, right, which are perfectly acceptable for exercising the system, you can build 2 games to stress the different parts of the system. So many tiles I have in pixels for how big each tile is. I guess I'll do the same for UV sprites. And it never... Yeah, I'm gonna have to do that because the idea I have, the main driving factor of the game would be sound. You know what? I had an idea for a sound-based game, but it would be too small for a game on its own, so I was thinking of it as like the first level, and then it would shift into something else, which I have sitting in my back pocket, but I don't know. So I had the idea of playing just as a blind. Your screen is just black, and everything is sound-based. But I don't think I could build an entire game out of it that way. I think as a first level, you start out blind, and then you move into a different kind of puzzle game once you find the magic potion or something. It's magically induced blindness, so. But you had the same idea? That's kind of funny. I had the same idea. Every time you touch something, you see the outlines of objects. Oh, okay. Okay, I did not have that idea. I was going to literally have them just be blind. Literally just sounds. And it, just barely enough to make you move through a couple of rooms blind. Then you'd find the potion that would fix you. Then it moves into a different kind of puzzle game, but you'd be able to then hear the same sounds and see what was actually going on. Could be kind of fun. But yeah, touching something to see the outline of objects, that could be kind of cool. That would work really well in like a claustrophobic, like space station, alien invasion kind of setting, right? That would increase your tension. Yeah, there's a number of movies that do like sonar visually. I guess some of the different Daredevil takes have done something similar. Yeah, you can do some cool visual things with that. That would be cool. I would play it. It's really hard to touch the sky, I agree. And if you do and it's outlined, I don't know that it helps much. So you don't have any game ideas about learning a language, do you? Because it sounds like we're kind of on the same page in a few design ideas. Yeah, for Sky, you want like, I mean, like, what is it? No Man's Sky? Is that the name of that big space one where everything's randomly generated and pretty solid little game all on its own. So it's not printing out my thing. Oh, well, that's because I didn't update the data file. So if we go UV Sprite, there we go. Wrong outputs. It's trying to open a file. And failing. So, load PNG. I mean, another good setting for big skies are, you know, like Wild Western type of games. You could do like a weird Western. Go out on the plains of somewhere and shoot werewolves and zombies. Gotta go, pretty tired. Good luck with your sprites. Thanks. You have a wonderful evening. Thanks for dropping in. Thanks for the raid. Oh, I should give a shout out to you since you're here. AK Elements. I can type right. Yeah, thanks for dropping in. Anybody who wants to should go follow AK Elements. He's building his own game engine from scratch. Pretty cool stuff. He's definitely on a different level for me, so give him a follow. You have a good evening. Okay, so it's getting confused. Error code, whatever. I want a file name. I'm willing to bet that's the issue. The file name we're getting is just wrong. We've not exercised this part of the system, so we haven't had sprites until now. Spin failed to open. Okay, so what is it going to spin? Oh, UV sprites. Maybe if we just change that string. Let's just be consistent everywhere. Let's just singularize tiles and sprites. I'll bet that was the problem. Oops. There we go. And then in our images text, UV sprites in. Okay. So rebuild this, run it again, then we should get things going. Yeah, these are not rows and columns, these are pixels. That actually makes sense. Sometimes you need to pad. So for example, if we go back to I guess maybe the journal's the best way to show this. If these don't have a power of 2 nice divisor, you might just end up with a row of trash pixels at the bottom or at the right edge. So the fact that you can set the tile size is better than saying rows and columns. It's just always assumed to be from the top left, moving right until you run out of pixels, and then down until you run out of pixels. So there can be a fringe. That makes sense. Let's define it that way. I do not have row count. I have. It has a width and a height. So that makes sense. If we just did that, we can re-embed, yeah, 32 rows by 32 columns. Now, that printout is incorrect, but, wow. We go to our image warehouse. We find our test coin. We have a spin animation, 0, 1, 2. So it's not getting. It's doing the same thing that the tiles was doing. It's not going through all of it. Okay, so we just have an issue where we're writing it. There we go. In our sprites. For y equals 0, x equals 0. So we're going to go row first, so the y doesn't change, then column. As long as y plus h is less than height. This is my tile, my sprite height. It's less than equal to, right? We're adding those. There we go. I expected 8 frames, and we got our 8 frames. Okay, so now we need an offset and a count. So we can package multiple animations in a single sheet. You know, we should do also, we should go ahead and just test while we're in here, images, not text. Just try tiles. Oops. Run that ImageWarehouse. Okay, so we need to update the tiles as well. In the same exact way. It's we basically did the same thing. This is basically a copy paste in a lot of ways. We're gonna make it a little bit better. ImageWarehouse. Okay, so there we go. 4 by 2. There's 2 rows and 4 columns. Perfect. Okay, so here's a couple of to-dos that we may want to do someday. To-do tech. We're not going to use tiles, so embed PNGs or UV tile should also output a UV key 2D array. We can look up UVs by tile coordinate. UV Sprite should also output a UV key array, so I can look up Sprite UV keys by animation index. I don't know if we'll get around to that today in any way, but we'll throw it in the list. It sounds useful. Okay, so we're not doing tiles though. We're doing UV Sprite. We're going to spin 32. Now what we want to do is extend this a bit. We're also going to change the way we do this. So here in UV tile, parse this out a little bit differently. Modulus D, X, modulus D. We don't need the parentheses. We're going to do the same thing here in UV Sprite. So that'll be the width and the height. It means in images.text, it would be 32 by 32. Then we need a range, I guess, right? I don't remember how big data is. Let's put something in here. UVs.data. I gave myself 8 integers. So I've got room. So we can read in X by D's, that's our frame width and our frame height, from some index to some index. Data plus 2 and data plus 3. That won't affect our output at all, except we'll see the output. Here, so it's 32 by 32 from 0 to, what do we say? 5? And this is inclusive. Go idle from 6 to 7. Let's compile this, run it. Okay. UV Sprite spin from 32 pixels from frame 0 to 5 and 32 pixels from frame 6 to 7. So that seems to be correct. Therefore, data 2, data 3, where we output our sprite, UV Sprite. With height. And start equals data sub 2 and end equals data sub 3. If sprite count is less than start, you know what? Start less than or equal to sprite count, and sprite count less than equal to end, then we do output. But we always increment our sprite count. Okay. Oh wait. Is that really what I wanted? Start putting the UV key underscore sprite count. I actually don't want that. Okay, so this is actually called the Sprite count. Frame count. Okay. So that's one piece of this puzzle. We'll just try that. So our image warehouse now. 3, 4, 5. Perfect. There we go. And then idle 0 and 1 will point somewhere else. So that's fine. Okay. I think if there's anything else I need. Okay, go back to warehouse.cpp. This is going to be a bit of a fun thing. Spin underscore. Oh. Might take us a minute to find this. Okay. Okay, so it has names for some things, and these are wrong. So that's one. Oops. And then our UVs also are doing the same thing we had before. But overall, not bad. Okay, so let's go back to embed. Get G's. Oh, well, that no longer works for sprites. Sprites are different now. All right, let's go to UV tile. This is less than equal to, less than equal to, less than equal to, less than equal to. Okay, if frame count is between start and end. Start frame less than or equal to frame count. Frame count less than or equal to end. Frame or end. Or end. Oops. Okay, so I should fix one thing. The other thing it needs to fix, that UV count. It's always going to be a problem, isn't it? There it is. Okay, sprite count. Start less than equal to frame count, and frame count less than end, which doesn't exist yet. And start equals data sum 2 and data 3. Okay. And these are less than or equal to. Okay, we're getting there. Run it again, and our ImageWarehouse. All right, big file is fine. Spin 0, 1, 2, 3, 4, 5, 6, 7. Even though I said limit yourself to limit yourself from 0 to 5. So that didn't work there. Entry count. Test coin should have a lot less. We'll figure that out in a minute. Okay. So spin 0, 1. Whoa. Okay. 0, 1, 2, 3, 4, 5. Idle 0 and 1. So it worked here. This down here did something a little bit goofy. I don't expect those to be idle 0 and 1. And then obviously the count is wrong, but we'll figure that out in a minute. Okay. I think we're close to having what we need. I need the place where we write out the UVs themselves. UV rectangle, UV tile. Right. Oh. That probably fixes it right there. Okay. ImageWarehouse. Reload. 18, 19 megabytes of text, actually. Oh, so close. Obviously missed one of the equal to. Yep, there's no equal to there. Okay. So let's run this bad boy and our image warehouse. Twenty megabytes. Go to the end. Now we have the UVs here. Perfect. And does the idle look right? So 0.5.5. I agree. 7.5, 0.71, 0.5, 1. I agree. 0.75, 0.5, 1.5, 1, 0.75, 1. Yeah. So these UVs look like they're being calculated correctly. Good. Good. So what we need is our Sprite class. We have the data we need for both methods. We have the images themselves and we have the coin. Oh, this count is wrong. This is literally just 8. So we're double counting somewhere. Double counting. UV count. Start index is probably right. It's the entry UVs count. Okay. This only works for tile. Image UV count plus equals data sub 2, data sub 3, and these are inclusive, so we have to add 1. I think that's it. Okay, then image warehouse. Now it's 8. Test coin has 8 UVs. Perfect. Except this is not right. Okay, so where we went. I just want this text here. Right here. Boom. There we go. Now, there are some assertions we should probably make. Let's test this real quick. The assertions go something like this. 8 and 12, 1 and 9. Yes, perfect. Okay, good. So in our embed PNGs, when I read a UV sprite, here, I'm going to read out 4 pieces of data. We want to assert certain things about our data. Assert data 0 is greater than 0. Oops. Assert data 1, data 0 is less than our image size. I'm not sure I have the image size at this point. I don't think we've read it. 2 and 3 should also be, let's see here. 2 is the start index, so that can be 0. Less than or greater than or equal to 0. Minus 1 must be greater than 0. And assert that data 3 minus data 2 plus 1. I'm going to use parentheses. Assert that this is less than data 0 times data 1. There we go. So basically, you told me that I have to go between frames whatever and whatever. So that'll need 6 frames. Do I even have that many frames? Except this is not quite right. It's the no, I don't think we can check that. So let's just check that data 3 is greater than data 2. That should just work. No major differences on our side. Should just happen. Okay. But when we are writing it out, we can test more things. So UV sprite. Here, when we're actually writing things out, we have width and height information, which we got from somewhere for the current image. So here we can assert those things. Here we can assert that width is less than the image width, height less than the image height. we will assert that n minus start plus 1 we insert that end minus something. The end has to be. Let's go grab those other asserts. Let's just put them all in one place. Okay. So read it in. We don't assert until we use it, which is here. These are the simple assertions. And actually, these don't have to be 0 and 1. These can be W, H, start, end. End has to be greater than start. I think this is a little bit more readable, so already a win. Okay, so start has to be greater than or equal to 0, and then it has to be greater than start. Actually, that's it's that checked, so that doesn't matter. Check that our width and height are fit within the image. Then we need a row count. Basically, n has to be less than the number of rows and columns we need. So XYZ, let's search for row count. Here we are. That would work. This is just width and height. Instead of data 0, get width and height. Assert that the end index is less than row count times column count. Basically, how many places could we possibly put a frame? Okay. Boom. So that should insert a bunch of things, make sure that what we're typing in makes some sense. If not, we can test as images, not text. We can say we go out through 8, which should not be possible. They should fail on assertion. Yep, perfect. Okay, we don't need that one. That's a fake one. We can leave it in though, it doesn't hurt anything. Okay, now we need, everything is good, everything looks fine. We need, what do we need? We need a sprite animation object. I think we have all the data we need in either case. Okay. Yeah, I like this. This is gonna put It's gonna make the animation tracking pretty easy, I think. Oh, kind of. There's one thing that would be really nice. I am thinking, so we made those to-dos way down here at the bottom. I've thought about it, and I think these might be doable today. Okay, so what? We needed to update UV Sprite in embed PNGs to have frame offset count. That was one thing we decided. Two, I think what we need is a method. ImageWarehouse method to get tiles UV key by tile coordinate. To get UV sprites UV key array. So we can look up sprite UV keys by animation index. Okay. Is there anything else here? Okay. ImageWarehouse. Let's go pull up clean and build. Oh no. Huh. ImageWarehouse didn't finish. Well, what have we done? Hmm. There's something wrong with the embed PNGs. We output something with sprites. Hmm. So what is it doing then? Oh. Well, I mean, that's not the issue. Let's do a build. Target equals embed PNGs. Oh. Yeah, because it did that. Now ImageWarehouse. Probably completed. Yeah. Okay, clean and debug build. Thank you. There we go. As long as this builds, we'll call that first task done. Okay. We usually take a pretty meandering approach when we're inventing a new feature. Not by inventing, we're just working our way through a problem that's been retread many times. This isn't rocket science, it's just putting it in our own system, in our own terms. So that worked. So journal. Shader animation class. Okay, so updated good PNGs to take into account UV sprite frame ranges. So we can compact multiple animation sequences into a single texture. Fix a bug or two with UV tile and UV sprite while we were at it. Okay, we get the description what we did. Okay. We'll add everything. Yeah, nothing unexpected here. Add PNGs to have sprite animation frame ranges. Basically. Okay. Anything else? Okay. So now what we need is a sprite animation we can do a couple of things here. Right, the options are things like we could inherit from texture quad. We could have a texture quad member Then we can have delegate methods. Like that texture and whatnot. Or we could just expose the texture quad. Like that. Each of these has its upside and its downside. If we do this, texture quad has to become a child of this. And we have to call set parent set child. There's an additional transform applied every frame. And really, sprite animation is a texture quad that just has a timer and an update loop. Oh no. Well, okay, so here's a possibility. I'm trying to think where sprite animations might come from and where they might go to. So our current animations are all provided by the scheduler upon request. Don't think I want a sprite animation to do that. So my previous thought was texture quad would just make me not have to do this or anything like that. I could treat it like a texture quad, except it also has basically a timer attached. But do I want the animation? No, I don't think I want to do that. Okay, so here's the new. Is it the new plan? I mean, no matter what, we need a texture quad to be included. And instead of owning it myself, I think I'll do this. Okay, so I can think of several different possible use cases, and I got to think about what's necessary to implement and what's not. So one, this animation could create its own texture quad on the fly as needed. If this is null when we try to do things, it creates one and then owns it. Or it just owns the texture quad. Do I want this managed by the scheduler from an asset pool? Maybe sometimes? This is interesting. I'm not sure how I feel about all of this. I haven't really thought the problem all the way through, obviously. obviously. I think it's more like a UI component than anything. So maybe it does just own its own texture quad. Is that how I want to do this? So you can set. Okay, well, other things we're going to need include an EggTimer. Then what? Well, let's just get this far. We should render the texture quad. Yeah, this is a puzzle. So this needs a render. I need to update. Because the sprite animation is going to be a little bit different. Okay. What else? I guess that's most of what we need to get started. Let's just get it to draw a thing on the screen. It'll behave just like a texture quad because that's all we're going to put in. Okay. Okay, turn underscore texture quad. Now remember what texture quad has in it. Angle texture. Okay, so render. If enabled, same thing for update. It's not good. I do need to write myself a note to do. Separate enabled into enabled and visible. Fine. Okay. Blah blah blah. Oh yeah. Okay. Texture quad. Okay. If it's enabled, underscore texture quad dot render given view projection matrix. That's basically it. The update loop is where all of our logic is gonna go. So this should be enough to get something on the screen, which would be like coin one or something. Settings scene. Oops, not settings, scene sandbox. And it's sound time test. I'm actually shocked at how well that went. I thought it would be a bigger pain. These all get commented out. Okay. Is that everything? Basically. Okay, we need a new test. Where did that sound time test go? Right here. Okay. Testing sprite animation. We need a sprite animation. Is that what we called it? We did sprite animation. Animation. Do we need anything else for now? I don't think so. Oh, we need the init update render kind of button maybe. There we go. All right. Okay, initialize our sprite test. We are going to take underscore, what are we doing? We'll call it sprite. Texture quad. Wow, okay. Quad 22 set texture to ImageWarehouse asset coin 1. Set rectangle. Let's put it at someplace. It kind of doesn't matter. I don't like the update rules here. Let's see here. So renderer scale versus scale x scale width. I don't remember what I called it. Renderer h. Scale width. Scale width to 100 pixels. X. 100 pixels Y. These are 32 pixels. I'll make it 128 by 128. Okay, update sprite test is m_sprite.update. Nothing crazy there. And render. There we go. Now, on render, we will render a sprite test. In update, we will update a sprite test. And we will init sprite test. Okay, so that should draw a single coin doing nothing on the screen. Pull up clean and debug. Of course, we have issues. Sprite animation was not defined. Alright, so I'm not seeing the header. We should probably include sprite animation. Nothing else showing up of crazy note. Wait. Okay, file one more time, but need clean this time. There we go. And of course, have to update this thing. So where's button? Let me put it here. Sprite animation. If we want to call it sprite animation, we could rename it right now to Sprite and just simplify our lives. And also make me not think Sprite should go in the scheduler. I think that's the correct answer. Okay, so we have to go then to sprite animation, rename file and buffer. To just sprite. Okay. Now that gets me partway there. What I need sandbox. There we go. I think that's most of what we need. Of course, we get the address. I thought I had changed that. How dare they? Cursor must have been below that point in the file when we did our rename. I'll be sad writing sprite animation over and over again. Okay. For the shell, if we run this bad boy, okay, / source builds debug, word sleep. Okay. Part number 1, sandbox. There's our gold coin. And now comes the spritey part. Well, here comes the initialization step. We want to set an animation. Let's think about how we want to do that. We said in our journal an array of textures is the way we could do it. So ImageWarehouse assets could do this. Because the other thing we would need is an ImageWarehouse UV key be frames. Either way, we need a frame count. So images is going to start off as null. Frames is also going to start off as null. Our frame count will be 0 to start with. So question number 1. Is it question 1? Is who owns these arrays? And this is part of the, can ImageWarehouse just hand me these frames in an array, ready to go? That would be cool, in which case we would not own it. But we could also have it manage its own asset. So do we Boolean own asset? Okay, the other thing we need is an enum class for sprite type, which would be image array and UV array. You know what? We don't need to do that. Let's not be silly. For now, let's have this thing own the resources. So bool underscore owns resource. Owns the frame data. Okay, now void init image array. Init a UV array. set image at to an image warehouse asset. Or set UV at, which would be an image warehouse UV key. Let's make a nice little helper function. Clear. It's not what I copied. Sprite needs to clear out its resources. If if we own frame data, for the owner of the frame data, if m underscore if images is not equal to null, delete m underscore images. M underscore UVs is not equal to null. Delete m underscore UVs. And whether we're owner or not, following has to happen. M underscore images has to equal null. M underscore UVs has to equal null, and M underscore frame count has to equal 0. Boom, done. Okay, so that's clear. So if we initialize an image array, first thing we do is clear any old data that we have. Here we assert that our index is greater than or equal to 0, and our index is less than m underscore frame count. This has to be true. Otherwise, m underscore, oh, and also assert that m underscore images is not equal to null. UVs, okay. And quite simply, m underscore images at that index equals our asset. Boom, done. That was a simple and terrible way. So m underscore images equals new image warehouse asset array of frame count. M underscore frame count equals frame count. UV key. If we initialize it, then m underscore owner equals true. If we clear. We're no longer the owner of anything, so I can go back to false by default. Okay, this leaves it open so that we can also do things like set image array or reference an image array from somewhere else and not be the owner of it, not clean it up. Clear, do things. Okay. So in theory, we could print out the sequence. Should make a little log function. It's going to make debugging easier as we go. Let's make a log function. Void log. Always does. Okay. Now, our texture quad gives us no way to see what our texture is. Or what the current UV is. So let's try a couple little getters here. Void. Const texture. UV. Oh, maybe texture has that texture. HPP. So we get the texture index. What UV data do we have? Interesting. Oh, name. I think that just makes my life easier. Yeah. Okay, so that's good. Currently at thing, which is _text quad texture name. What else do we need? It would be nice if we knew the UV. Some texture quad, text quad. Set UV. Okay, easy. Now, set UV does things, but we don't actually store it anywhere. We should. Okay, so texture quad. And that is stored per vertex. It's not really a thing of the texture itself. So that makes sense. So where to put it? ImageWarehouse UV key. Which means now we can get it. So this is ImageWarehouse UV key, I guess. Sure. Texture quad, CP, texture. Oops. And we can get the UV. Turn underscore UV key. Okay. Texture quad, point to UV key. Image warehouse. I know it has a function to give me a name. Get UV name. Boom. Done. Okay, so let's just log that. Sandbox scene. And it Sprite test. Sprite log. Just make sure it's coming through and it builds. What? Okay, well, probably time for a snack. I'm getting tired of this gum, so we're gonna pause there for a minute. And I'll do a quick snack run. Just a moment. We got good snacks today. I made my kids whip up some jalapeno poppers last night, so this is great. All right, let's see what we did wrong. Oh, no. Here we are. UVs. We'll figure it out eventually. Okay. All right. So where are we at? Okay, we run it, pop in a sandbox. There's our thing, and we have coin.png with the default UV coordinate. What just happened? I did not quit. Did it crash? Why would it do that? I've never seen that before. That is a new one for me. What? Hmm. Okay, well, it could be. We're going to do a full clean. We've been making changes. I do like a nice jalapeno popper. Good stuff. Half out your jalapenos, scoop out most of the seeds. Seeds are what make it really hot. And even then jalapenos aren't that hot. They're toasty warm, but they're not that bad. And you load it up with about a 50-50 mixture of cream cheese and cheddar cheese shredded. Wrap it in a half a slice of bacon for each half. Cook them. Super good. Okay, it's not crashing. It was just the build. Okay. So that's working. Oh no. What? Why is there a sync fault? Huh. Huh. Hmm. What is this new nightmare? 36. Let's see if with each font. Equal to null. Sandbox, back, quit. Huh. Unload 51. What is going on? Something's stomping my face. Hmm. Up one, print the face. Huh. Alright, let's look up free type 2 documentation. There should be a way. Documentation. API reference. Face creation. Styles. So I can do bold and italics if I want to. New face, done face, new memory face, face properties, open face, open args, attach file, attach stream. Is there like no status? New, done, reference face. Okay, well, I'm not seeing anything in the documentation that would be terribly useful. So the question becomes, what does it become? That's a good question. underscore face. Okay. Like, let's see here. Print underscore face two known faces. Face index. Glyph. Huh. Family name. Okay. Something has happened to this font. Because we have fee. This has been working for so long. Why would it change now? Why would it change now? I do not understand. I do not know. Face is null. If we load an asset, we load a new memory face. Unload. Face is not equal to null. We've done the face. Huh. So something is stomping fonts for some reason. Okay, well, let's go to font store cleanup. Okay. Oops. That's not what I want. Continue. Okay. Now, font store.cp. Line 37. Rerun it from the top. Already got the same fault. But it shouldn't call delete. I got a breakpoint there. Okay, well, we can put a breakpoint there, breakpoint. Let's store that. CPP line 36. Run. I think something is stomping over the font store. I just have to figure out which one. My font capacity is 2? Oh, that's fair actually. I only have 2 fonts that I've loaded in. We're gonna print S fonts at 0 and at 1. Fonts 0. So if we do watch. Oh man, I don't know. This is one of those really fun to find ones where it's probably. Second one is null because we haven't actually loaded the font because we haven't needed it yet. So who stomped this thing? Watch S underscore fonts sub-0. Oh. Okay, backtrace. Watch S underscore fonts. Rerun it. Font set 0. Family name. What? This is an address. Hmm. Hmm. I have to watch. Okay. I make a new font and load it. That happens at line 19. print asset, and that's Francois. Then we can print index and print fonts at index. Okay, so that's a number, right? So we should be able to watch fonts at this index and continue. Watch point 5 got deleted. Continue. Put that is the same address, so that's good. Rerun it. This is an odd one. Right, so we go next. Print x underscore fonts at 0.2 Emily name. Okay, so that is a thing. That is correct. We can continue. We quit. Then we do the print, and it is invalid. Something is stomping over my fonts. Who's writing to my fonts? Yes, continue. I get a watch on font store s fonts at 0. Oops. Well, fine. Hit continue. Breakpoint. If I set a breakpoint or set a watch on a section of memory, and that memory gets corrupted without the watch ever being tripped, what does that mean? Can do that. Also want to break on load, right? Line 19. Breakpoint. Font store. Line 19. And run. Okay. Continue. Nothing happens until we try to quit. Huh. And the watch never gets triggered. That's not helpful for debugging. Okay. It is not the font thing itself that's broken. Something else is overriding memory. Or it's already being freed somewhere else. I mean, I'm pretty sure that nothing else does this. That's it, once in font. Do we delete the face? Start with null, we set it to something. Delete it. I mean, on the one hand, it doesn't matter. We could literally comment it out and it doesn't matter because this is only happening once when we end the entire game that it unloads the fonts. When those resources are going to be returned to the operating system anyway, so it doesn't matter. But if something is writing outside of its bounds, I'd like to know who is doing that. My debugger's not helping. Ooh, wait. Let's see. I did download a new debugger to try, because this one kind of sucks. Maybe it's time to pull that bad boy out. Let's see. Go to our downloads. Oh. Let's see. Users. Downloads. Did I not put this somewhere? Okay, so we're going to extract it all here. Oh. No, skip it. Yes. Okay, it's in over here. So let's go up a folder. There we go. Put it on my desktop. Let's see if we can get this up and running. We're going to run this. We'll try to share it. What's it called? The rad debugger. So share window here. Application, video, window capture. The rad debugger. Probably works okay. Yeah, we're not in debug mode here. Okay. Now we will open That's not helpful. Add target. All right, we go to the D drive. Oh, no. The dough. Oh, it's not double click to do things. Cool. Active projects. Word sleuth. Source builds. Debug. This one. Okay. Now what? Where's the run? Launch or F1 to open command menu? Whoa. Okay. Launch and run. Is it running? Is it doing something? Oh, there we go. Now it's launched. I have that thing which captures my console output. Okay, then we hit quit, and it blows up. Here's disassembly. Here's yes, access violation. Wonderful. We want to watch font store fonts at 0. I think yes, that memory has been worked, but I don't know why or who. I'm trying to clean up memory. Yes, I understand it's an exception. I know it's an access violation. Oh. See, it's all these question marks that make me mad. Ostensibly, there's supposed to be useful information in that. Unknown symbol. Like, I have built this in debug mode, so these are not useful. Ugh. Won't give me locals. Hmm. I mean, this isn't giving me useful information. Anyway, I couldn't set a breakpoint here. Let's add a watch. Oh. Font store that's fonts sub-0 could not be found. Of course not. Okay, never mind. It's Not being helpful. Blah, blah, blah. Well, shoot. Travest, time for bed? Yes, you get some good rest. We'll see you tomorrow for Compilers Day. Compilers are fun. Okay. I'm going to, because this happens during program shutdown only. It doesn't actually affect any of our other testing. Bug. Font. Crashes during cleanup. During program shutdown. Watching font store 0 showed nothing. Somebody's overwriting that address, that memory, or it's being freed up at an unexpected time, like font store cleanup. Oh, maybe. I'm willing to try this. So what font does in its cleanup, this says we're done with the library. So we shouldn't clean up the library until all the fonts are cleaned up. In theory, maybe that's the problem. Maybe during the library cleanup it's doing something weird, but in which case that's been in there forever and hasn't caused many issues until today. Which would be just chalking up another stupidity to the GCC compiler. Very puzzling. Hopefully this just fixes it. No. Exited normally. Well, crab juice day. Sandbox, which is what we were trying to test in the first place, quit. Yeah, so that'll unbelievable. Okay. Whatever. Okay, so Sprite log bool details equals false. If details, I have some options. If m_images is not equal to null, well, how about this? Just add m_frame count is 0. No frame data. Okay, what am I missing? Why is this not indenting? Oh, because there's not 2 columns. Okay. else if m underscore images is not equal to null, else if m underscore repeats is not equal to null, else why this following. We should never get there. Okay, so if images are not null, okay. All right. Yeah, I want to know how that font thing did not once show up ever since that line went in. I'm miffed that or int index equals 0, index less than frame count plus index. ImageWarehouse get asset name. Get key. Okay. And tab underscore images and our index. Okay. Yeah, by default, we didn't put any in, so it should be fine. What? Very strange. Very strange. Yeah, I don't know how that crash never showed up ever before. Okay, no frame data. So we should add some frame data. Sprite.init image array, 6 images, set image at, zero to ImageWarehouse asset from 1. 6. 1, 2, 3, 4, 5. 2, 3, 4, 5, 6. Just make sure we're loading up our rotation correctly. Okay, and now 1 frames. That's hilarious. Oh, frame count. Let's do this. Underscore images at index if it's equal to texture quad texture .2 thing texture index. Make it single space. UVs at this index. Right there, equal to m underscore. Let's see, where do I get the text quad dot uv? Indicate here is where we are in the sequence. Okay, so we're on coin 1, and we're on that sequence in this position. Okay, so all we really need now is play functionality, which is EggTimer frames per second. This is 6, so if we want to go around once per actual second. Six frames per second is not very many frames per second. But if we did like 30 frames per second, it would go around 5 times per second, which is kind of quick. So it's all coming together nicely. Sprite. All right, so we need a int underscore frames per second. The default will be 30 frames per second, I guess. So I'm just going to get set and get for that. There are some questions to be had here, but we'll not talk about them just yet. So the reason we probably want to keep this one private, not just make it public, is because when we change the frames per second, we will have to manipulate things about the timer to change how long it takes to switch. Okay. Sandbox scene. Sprite.set frames per second to 12. Okay. We'll build all that logic in soon enough. Okay, so 12 FPS. Okay, so it's all now about the EggTimer. Input is key pressed. We'll use the space bar, I guess. There isn't a function for that yet. Okay, now with Sprite needs a function called void pick, I guess. Or being. I'll just call it being. Okay, when we being. Okay, wow. Okay. Log note being set frames per second to 30. Okay. EggTimer set duration to 1 over FPS. So if it's 30 frames per second, we want to trigger every 1/30th of a second. Okay. M_underscore EggTimer dot set. Let's see, what's it called? Set callback. Okay. do this ding. Frame index. So when we ding, our frame index increases. If m underscore frame index is greater than or equal to underscore frame count, m underscore EggTimer dot stop. I would like to start. Ding. Done. Okay, so I need the start function, and that should be about it. As a rough stubbing in of everything here. We need a lot more than that, but start. Let's see how this goes. There's a lot of safety, a lot of features like loop, repeat, reflect that we could go through, but let's just see if this even does a thing. So we hit spacebar, and exactly nothing happens. Oh. Okay. Underscore EggTimer dot update. It will not ding unless we actually our ding set single shot false. We want this thing to fire off multiple times until stopped. Okay, sandbox. Spacebar. Okay. So ding 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 ding. Done. That looks correct. Cool, cool. Now we just fire it up. On a ding. Otherwise, this logic here. If it's images, we do one thing. Log error. Oh. Not enough controls, protections yet. Like, we could get here easy enough. Sprite.ding. Okay. So it should ding either way. But then the important thing is that we do m_texture quad dot set texture equal to images m_frame index set UV texture quad set UV at m_UVs at the frame index. Okay. It starts spinning. We might be in good shape for like Monday, having everything we want done on sprites. Ready? Spacebar. Okay. Okay. Oh, start done. Yeah. Start. Well, that's not necessarily true. Because we have start, pause. We do not have a, like a loop option. So we could set this back to the original. So if we said we want 7, back to point 1. So that's a thing we can do. And for now, we're just gonna have to start to do that. So. But overall, on start, we could set it to 0. In fact, we probably should. All right, so spacebar, full rotation. Everything there looks correct. Full rotation did not do anything. Back, quit. Org. So on start, I actually want frame index to be -1 and ding. Oh, not frames per second. Whoa. M_frame index equals 0. -1. We fake a ding. Then we start. Spacebar, full rotation, full rotation. Perfect. Okay. Now, one thing we can, well, So that's for UVs, or for images. So let's have two sprites. Sandbox scene. Sprite 1 and Sprite 2. Okay. That worked shockingly not too bad. So now we just need to initialize Sprite 2 in a similar fashion. Down here, but different. We'll start both at the same time. This one we'll put at 250, I guess. Init UV array set image at to set UV at. UV key. I don't know what they're called. ImageWarehouse.h. Spin 0, 1, 2, 3, 4, 5. One, two, three, four, 5. And back to 0. You know what we're gonna do? We're gonna do this one backwards. 6, 5, 4, 3, 2, 1. Spin 6. Not a thing. I suppose that's true. 5, 4, 3, 2, 1. Wait a second. We go coin 1, 2, 3, 4, 5, 6, 1. So 1, 6. Oh, so this is 0. And the render sprite 1. Sprite 2. Okay. Hopefully the UV one works just as well as the other one. Take a look. to, oh, this one did not. Oh, it has default. And it has the wrong thing. Okay. Okay, let's go do our initialization correctly. This is not coin one, this is test coin. Set UV, ImageWarehouse, UV key, spin 0. What happened to my shell? Huh. Build Steam. Kind of doesn't matter, but okay. Sandbox. There we go. Now we're at spin 0 and spin 0. Oh, same thing up here. Cute. Okay. Boom. So we fake a ding. And this is the reflection of that one. We're spinning it the other way around. Cool. Cool. Haha. Okay, now things get fun. Now things get fun. Okay, we should. Firstly, clean up a lot of this log stuff. That's tracking. This log function is fine. We don't need to use it anywhere unless we want to. Ding says done. So there should be no. We could spin them even slower. We could spin them over a second. Let's go to sandbox. Six. This is gonna be choppy, but okay. All right. Let's take the log out of there as well for now. Quit. I think we're basically there. In terms of the core functionality. Boom. Boom. Very nice. Okay. Now. Shader animation class, which we are renaming to that. I don't know if we're going to need one of these today. What are we at? 4 o'clock? Animate and image-based sprite. Animate a UV-based sprite. We've got both of those. Now, things we need to do. We need to add more sprite controls. Start, stop, pause. That's the thing we need to do. Make sprite operations safe while running, or assert, or debug log. Or debug log when not. Like there are some things you can do safely while the sprite is running, while an animation is running, but others not so much. Other things to do here. Again, we're not going to get to all of this. Frames per second is working fine. Okay, easy. This asset pipeline's already been updated. It looks fine. We're using a texture quad, index, offset, and account. That's fine. Okay, so repeat, loop, and easing curves. Those are reusable things, I think. At end of animation options, reflect, loop, close loop, or okay, so so I'm just thinking out loud. What if so if you said reflect, it would literally just go from 0 to 6, 0 to 5, and back. Oh, right. So go bonk, bonk, and done. If we have loop, it goes 0 to whatever, and then back to the beginning. Close the loop just basically puts it back to frame 1. Just to finish it off. And then we wouldn't have to have that extra frame in there that we do. Okay, so maybe that reflect, repeat. So this is starting to look to me like it would be cool if I could basically create a sequence out of this and say, when you hit the end, reflect. When you hit the end of that, repeat. So we go back forward. So you can say reflect, repeat. Close just puts it back to, or end, back to frame 0. And stop. And at start, or just end, basically stops the thing. It looks like we could just set up basically bytecodes in an array and say what operation we do at the end of a sequence of things. This is interesting. Loop end of sequence end action array above item. So we could say start at 0, go to the end, reflect back to 0, repeat, so go forward from 0 to 1, and then reflect back. So we could say reflect, repeat 3 times. Or we could just say repeat 3 times. This is interesting. That might be kind of fun. Okay, what else do we do? Easing curves for timer. That could be kind of fun to mess with the time that way. Anything else we really want in here? Anything else? Okay, so let's go down to our nodes. Let's see here, Sprite. Now play either an array of textures or a single texture with UVs. Both are being tested in Sandbox. Several features. Suggest themselves or improvements. Yeah, this is good enough. Not safe to use yet. Just the full functionality. Okay. I think that's actually pretty good progress today. I kind of thought I would do just the one. It turns out they both are not that hard. Out of curiosity, how bad is my performance? This is 3,000 frames per second. Yeah, there's not even a blip at that rate. We make our frames per second for this one 12. Now these have the same exact properties that the EggTimer has always had, where we can set it to real time or scaled time. So that's always an option. Oops. Let's put that in the journal. Okay. Nice. Okay. I just guess we add it all. Basic Sprite functionality is present. List of improvements ready to work on. Boom. Nice. Okay. I think that's pretty cool. That means we can use this thing within a action sequence without any problem. Set of an animation. Like we can move this thing around while the sprite's running. Yeah, this is pretty good. I like the way it's going. Okay, so let's just fix up some things then. Here in the journal, we need more sprite controls. We have some start concept, but it's not great. Stop pause is running. Start will need to change. We can steal this from not that one. This one. Boom. Yeah. Okay. I'm going to sort EggTimer.use scale time underscore EggTimer dot is running. Okay. At start, I like this initial ding and then a start. Changing whether we use scale time or not. That is the kind of thing that we usually discourage, right? Animation. Let me think. So if we're running, we should not be able to change that. Okay, setting frames per second. I do not want to be able to do while I'm running, I think. Or we could pause. If we're running, we should pause. No, cool. Running equals is running. If we were running, we should pause. Then do things. If we were running, we should start. Okay, because we pause and resume, then the start will just continue. So that's fine. Right, we're left off. Okay, if it is running, what did I call that? We did a debug statement, okay. Okay, if we are not running, I guess a reset would be good. Start, stop, pause. You should definitely not be able to do while you're running. Underscore Sprite. Let's see, what was it called? Something index. String index equals -1. EggTimer dot reset. Okay, we're not running. A lot of these debug statements are not necessarily to prevent anything terrible from happening, more just to tell me that my logic elsewhere in the program is wrong. If I'm giving a pause command when it's not running, it's that I haven't thought through the flow of information correctly. So whether it causes an actual issue or not, it does indicate other issues. Not running. Same thing for pause. Underscore EggTimer dot pause. Okay, so where are we at here? Start, stop, pause, reset. Okay. Is running is easy. Using scaled time, easy to check, easy to change. Frames per second, set frames per second. I think that's reasonably safe. If we're running, we want to pause. If we were running before we pause, we want to resume. And this, oh, yeah, that's correct, okay. Okay. Initialize and image rate, yeah, definitely not while we're running. That's a terrible idea. And for now, I don't see any reason to allow any of this to happen either. Like, you really should stop it to do these kinds of modifications. Okay, render doesn't matter, update doesn't matter. Log, ding. Ding is something I control, clear is something I control. Okay. So that should all be clear as mud. I think. Okay, so that's good. And we kind of did both of these, so as long as it tests out okay so far, we'll fix any other bugs when we run into them. I don't want to fiddle with those just yet. We might push that up to tomorrow. Where are we at? We're not even at 5 o'clock yet. Let's test this real quick then. Do a full clean. All right. I think this is basically the last feature. Yeah, cool. Last major feature. We're going to start clean up and polish sometime next week. I don't think this Sprite stuff is going to take me any longer than that. So if we run this, we go to sandbox. Okay, so let's do a couple of quick tests. Sandbox scene in our update. I think it's escape. For pause, let's go with backspace to reset. I need something else for enter to just full stop. Okay. Okay. Okay, sandbox scene. Yeah, okay. There we go. So spacebar starts, escape pauses. So I should be able to say spacebar escape, spacebar. Okay, so hitting escape while it's running shouldn't do anything. What happened to spacebar? Enter is a stop. Backspace is a reset. Okay, so we can't start while we start, and that's good. Okay, hold on. Ding. If we ding and it's over, just color on the stop method. There we go. Okay. Now we hit spacebar, spacebar, okay. Spacebar, escape. Spacebar. Escape can't be done multiple times. We cannot start multiple times. We can start enter. Which one was enter? Okay, so enter was stop. So it had to be running. And it reset back to 0 because when we hit spacebar, it's going to snap back to frame 1. Yeah. Then we can't reset while we're running. So if we go spacebar and then backspace, okay. Spacebar escape, backspace, okay. Reset. Should reset go back to frame 1? That is a good question. And ding. I kind of want to. All it requires is this. Okay, so if we spacebar escape, spacebar escape, ding. Okay. Yeah, kind of like that. Which means, actually, in sandbox scene, we don't need this one or this one. We only need 6 elements in our array because it will snap back to the beginning and at the end. It may not be entirely the right choice, but we will come to end of sequence controls in a bit. Right, sandbox. So okay. All right. I think that's that for that change. So journal. We added more sprite controls. The sprite operations that we can change, we have changed. Throw in easing curves just to see. Okay. Added and tested or play controls. Stop. Reset. Pause. Real versus scaled time. Most methods have checks for running state and log any issues. Adding more play controls and Real versus scaled time. Okay, I do want the easing curve thing in here. If I go to right, so here's a question is, do we want T and P parameters off of our animation as well? So let's see here. But an animation has an easing curve and a T. I think an EggTimer has a T parameter, but not a P parameter. Actually, does an easing curve even make sense for sprite animation? Select rotate. And it would be over the full sequence of the run, which would be a stopwatch. Or it would be over the sequence, since we can possibly do different things at the end of a sequence. Maybe easing curve is not the right ask here. Let me think about that for just a minute. At least partly the question is, how would I even implement it? The idea is basically to change the spacing between each frame. Over a run. Yeah, I don't think that's a good idea. Because with loops and flect and repeat, the question per sequence of actions. Do we add it per sequence? No, I don't think this is a good idea. We're going to remove that from the list. There's too many ambiguities and yeah. Okay, so at the end of each animation, already have end at start. So that's done. Oh, no. I have to. Okay, so how do I want to do this? An enumeration of options, probably. EggTimer, not EggTimer. Sprite. Enum class. End of sequence operation. End end and reset. Stop versus reset, that's fine. Repeat. Reflect. Okay. And a sequence op underscore and EOS ops. Static constant non-EOS and of sequence operations. I don't know. Doesn't matter. M underscore US off index. Yeah. Not static, not const. Oh, this one is. That's fair. Index equals 0. Index less than the max number. And the sequence operation will be reset, I guess, is the default, right? Okay, yeah, this does get some interesting notions here. If we're at the end of the animation. The sequence operations, EOS index. All right, and sequence operation, whatever. Stop. It's not quite so simple problem. Reset. So this is the stop underscore string index equals -1. EggTimer dot stop. And underscore EggTimer dot stop, we do this, and ding. Repeat. Really actually doesn't do anything except for m underscore frame index equals 0 or -1 and ding. And then reflect could be fun. We do the reflect. Couple of ways to do this. Boolean underscore is reflected. False. Ding. I think this basically happens no matter what. Actually, let's do that outside the switch. If we hit the end, we cannot be reflecting unless true. So repeat and reflect do not stop the stopwatch. Only a stop or a reset does that. If we were very clever with fall throughs, we could probably make this a little bit more interesting, but okay. So by default, everything should just go to reset. Oh, reflect. If we're reflected, we do things one way. Frame count minus frame index. Otherwise, just take the frame index. It's one. I'm not sure. Well, if it's -1 goes to 0, frame count. Yeah, so it has to be 0. It can't be -1. Oh, so we get a -1 here, which is bad. Okay, then we get the old index here or here. That's basically it. Maybe reflect is the wrong word. Maybe reverse is a better word. set it to last frame. Maybe this. Okay. Let's just run it. Make sure it compiles and that reset just works. Oops. Okay, sandbox. Spacebar. Okay, so reset seems to be working. Okay, set image, frames per second, etc., etc. Let's do, it's probably more nearly here. Void set end of sequence operation. One other thing we would have to do, oh, this gets a little bit more complicated with this, but it's not too bad. So this comes in after it is running. You definitely can't do this while you're running. Okay, so then the sequence operation can do things. Otherwise, oh, we need an int index. Assert index greater than or equal to 0. Assert index is less than max and sequence operations. EOS ops at this index equals the op. That's basically it. Okay, stop, pause, reset. EOS op index equals 0. Everything but the ding, I guess. That's probably the correct answer. Index -1, thing reset, no ding. So these both do stop. This one does ding. Okay. If this happens, we get our up index. if underscore EOS op index is greater than X end of sequence operations. Stop. If we've run out of things to do, if we're off the end, we just stop and reset. Otherwise, we do the action. Stop, stop, ding, ding. Okay. Okay. Set end of sequence operation. Let's make sure this compiles. I haven't put anything too major. Spacebar. Okay. Therefore, in sandbox scene, we should be able to make some changes here. So Sprite. Oh, and the logging. Could improve the logging. It's fine. Set end of sequence operation to at 0 to Sprite end of sequence operation. Repeat. Oops. Two, and then a reset. Should be fine. This one will be somewhat similar. The log after that. We will eventually be logging these things. Reflect or reverse. Repeat. Reverse. Repeat. Okay. Three, four, stop. Repeat, repeat, repeat. Three, four, reset. All right, let's see how that works. Old sprite animations. Testing in our sandbox. Okay, so 4, 3, 4. Repeat 4 times, then stop, not reset. Okay, so reverse, repeat did not do what we wanted. Reverse means it should spin that way and then come back. Okay. Hmm. It is reverse. Yeah. Okay, let's see now. What? What? So full clean debug. My config file get blown away or something? We have run this many times and it's worked every time. Yikes. What? Let me go delete my old config. Not sure why that would be. And there's no way for me to now find out why, unless there's something very my config file is completely empty. So something we did somewhere crashed it. Okay. Run it. Sandbox. 4, 3, 2, 1. Okay. Even if the numbers just show up right, that'll be good. This is probably more control than we absolutely have to give. We could accomplish these same things with the sequence action. But I'd like to set up, semi-complex animation sequences within our sprite before having to resort to action sequences to manage more complex things. I think that's the correct answer. Okay. Now. Reverse repeat. Oh, wait a second. I may be looking in the wrong place for a bug here. Sprite one. Okay. Okay. And stop doesn't close the loop. These log statements actually don't help at all because that's just the way things go. So Sprite. Okay. So I think we have some different options for the way that it should behave at the end of a loop sequence. So this one's just spinning continually. This one goes back and forth. Cool. Okay. Now. Added end of sequence operations. Reverse. Repeat. Reverse repeat, stop and reset. Where are we at? 503? Perfect. Sprites now have end of sequence operations. Whew, okay. Now, last thing we really want to add is loops. Um, um, okay. I'm going to pause here for a restroom break. While I think about it. Be right back. Perfect. Okay. So loop. I guess we need a variable for loop. That's probably the first thing. Right. Count and loop index. We're going to default to 0 loops. Start, stop, reset. There we are. I think basically everything else happens inside of ding. Set loop count. Loop count. Just do the bookkeeping part first here. Okay. We'll start with this. Gosh, it's probably better. Okay, so that's all the bookkeeping side of it. Now down in ding. Oh. Okay. Loop. How do I want loop to work? There are some interesting implications to what we could do and where it belongs. So this is all normal operation. Let's do this. So let's just get this off code operation like this. this is end of sequence op equals the current thing. This be the same op. So if loop count is greater than or equal to 0, so 0 means we don't loop, we just run it once. Oh, ooh, interesting. Say if it's, yeah, it's greater than 0. So loop is probably 1 default. I think that's going to be more intuitive for everybody. Me, mostly. If it's greater than 0, then underscore loop index plus plus if underscore loop index plus underscore loop index. It's a stop or a reset. Oh, shoot. So basically, we hit things like repeat and reverse. It doesn't even worry about loop indexes, but stop, reset, and this thing do. We do not want to stop and ding if we have another loop to go. If loop count is greater than 0, and loop index is greater than or equal to loop count, then we do that. Otherwise, EOS op index equals 0. In the index. Sprite and the sequence operation op equals underscore EOS ops at EOS op index. Ooh, this is starting a little bit messy. Oh. basically at the end of our loops, if we're at an end of loop condition, you know, let's simplify this. Oh, wow. You should have a stop or reset action somewhere. Then stop and this is not a legitimate stop case. This is a wow, you never told me to stop. So here in stop, loop index. If loop index is greater than or equal to underscore loop. Oh, can't do that. We'll eject and loop count greater than 0. Pardon me. And then we're just going to loop if it's greater than 0 and loop index is less than loop count. Reject end equals false. That's just an error, so that's fine. If we reject ending, we reject our end, equals stop or reset. Then we do a repeat of equals Sprite end of sequence repeat. Obviously puts it back in the first time through the loop. And m underscore POS index goes back to 0. Does that make any sense at all to me? We tend to reject the end unless our loop is positive and our loop is greater than or equal to our loop count. Okay, rejected, false up. We get our operation. If we're rejecting the end, then we don't accept one of the stopper resets. Instead, we go with a repeat and start things back from the beginning. So, reset loop index. Okay. All right, let's try this. See if it compiles. For starters, then we'll wire up a quick test of that. Did it fail? That's always a good sign. Okay, so Sprite 1, we don't even need a repeat. We don't need to do anything here. We could say set loop count to 3, and it should spin 1, 2, 3 times and go back to its first frame. This one, reverse repeat, Sprite 2, so we don't need 2 reverse repeats, we only need 1. Set loop count to 3. So it should 1, 2, 3, and then stop 1 frame off the end. Oops. Okay. Oh, not folder. 2. My bad. Okay. We might need to do it clean. We did add the loop. That's probably going to cause an issue. So let's do it full clean. Okay. Just some tools in the tool bag. Okay. All right, spacebar. So we're watching this one. It's going to spin 3 times. 1. Huh. And this one never stopped. It's looping forever. Slow this down so we can see what's going on a little bit better. 6 frames per second. The code so we can figure out what we did. It's 3, we start at 0. Goes to 1. If we're at the end, that's not a good thing. We say we're going to reject stopping unless our loop count is a real number and our loop index is greater than or equal to. There we go. That's one thing. Then we're going to hit the op. If we're rejecting the end, We change a stop reset just into a repeat and say start over. Oh, if yeah. Then we continue on our merry way. This one calls Dean. Okay. Let's see what that changed. Okay. This one is looping forever. Did I copy paste or something? Sprite 1. Did it loop 3 times? That's a good question. Let's go count them. 1, 2. It only did 2. Let's at least fix that one. So it's 3, we come in at 1. Come in at 2. Loop index. Am I accidentally adding something else to loop index that I don't know about? Loop index 1. Oh, let's go 0. That would probably help. Some. One, 2, 3. Okay, this one has some issues, clearly. So that's the one we want to look at. And let's go back to this. Let's go back here. Let's just set the loop count to 1. By default. It should not be 0. 0 loops forever. That's my thinking. Okay, so 1 and 3 we've done successfully. So if we go to 0, it should loop forever as well. Then the question becomes, oh, well, it should just loop forever. Okay, so that looks good. So the only question then remains, this thing should loop. Oh, come on. Set this back to loop 3. Reverse. Repeat. Okay, well then that's that. So what's happening is Our ding logic is not quite right. Implicit repeat. Then back to the beginning. Our loop count to 1. 1 to 3. If loop count equals 3, that means we can log useful things. Log note loop modulus d out of modulus d, which is loop index loop count. Nope. If off equals stop or reset. We reject the end. Okay, so we look at our operation. If it's a stop or a reset, we increment our loop index. If our loop count is greater than 0, and our loop index is greater than loop count, we don't do anything. So this needs to be not. Our loop count is less than 0, or we aren't there yet. Then we take the repeat action and jump back to the beginning and go. I think that's better. Oh, Pat, ricotta, feta, mozzarella, parmesan. Just all the cheeses. You can never have too much cheese. You're out of here. Yep. Thanks, JTL. Glad to see you in here. See you tomorrow. Compiler day. No spicy fish. Yeah. One back. And now it's stuck again. No fish this time. Yeah, he learned his lesson. Speaking of dinner, I don't even know what I'm having for dinner. Probably find out here in a minute when I finish my stream. Get our opcode. If it's stop or reset, increment the loop index. If our loop count is greater than 0, and so on and so forth, we just let it fall through. Otherwise, you already know this is true. So basically coming on a repeat. And then ding. Oh. No, that's not quite right. I think I deleted an extra parenthesis somewhere. Sprite, end of sequence of reset. Otherwise, we get the normal operation. Close this one, the switch. Then runs. Then this thing runs. I think. When Sprite sheet is like just one sheet with all the animated frames next to each other. I used to do that type of animating a lot. I actually prefer it. So there's two things we're doing. The sprite sheet, the coin on the left side of the screen uses 6 different images. The sprite sheet on the right, the coin on the right, uses a single image with different UVs. It is kind of fun. It's going to let us do some cool things during the polish phase, I think. So, and then it's back to spinning forever. Shoot. There's a bookkeeping piece I'm missing somewhere. Yeah, so I actually have 2 methods. Like sometimes you just want a handful of images just to test things out and see how it looks. Then once you got it all done, then you pack it into a single UV texture, into a single texture, and UV map that sucker. I think that's what I'm going to be doing. Okay, so what bookkeeping am I missing? This loop turned out to be more of a pain than I thought it would, but, well, that's sandbox. Man, our test code got kind of big, didn't it? Okay. Tell it to reverse, repeat, stop. So what happens is, in theory, we go through reverse, we go through repeat, we hit the stop, and it's like, whoa, no, do a loop. So it repeats again and sets this index back here. Reverse, repeat. another stop, goes repeat, reverse repeat, then it should actually take the stop. So let's go take a look at that, I guess. Our frame index is greater than our frame count. Then we're looking for our operation. If we have one, so I've never seen this message, so let's just ignore that. Do log equals m underscore loop count equals 3. Okay. If do log note something. End of loop. So loop index loop count. Okay. I used to snag pixels based on distance from a coordinate instead of rows. Yep. So we're pre-baking our UV coordinates, but basically by the same reason. We know how big a sprite frame is. We assume that 0, 0 is at the top left-hand corner. And then UV coordinates are just calculated from there off the pixel sizes. So, yep, 0, then the offsets would determine what animation to play. So I've kind of got the start of something a little different. Let's see here, ImageWarehouse.each. So when we generate our UVs, I generate basically an offset to a UV. So in ImageWarehouse.cpp, you would basically use it to look up the UVs, which we pre-computed. So this is an index into the UV table. But yeah, basically the same thing. I just like that it pre-computes things for me. Where was I? Right. We had that build. Okay. So it keeps going to operation 3, which is repeat. Oh. Plus. We need a plus. I think that was my issue. Maybe. One, two, three. Perfect. Okay, now what I really wanted there, and I knew it would show up wrong, was this. The reverse is now implicit when you hit the stop on a loop. Basically, we want it to flip left, right, left, right, left, right, and then stop. So basically, it was flipping left, right, left, left. You know, it's, yeah. Because there was an explicit repeat and then an implicit repeat. So 1, 2, 3, boom. I feel like it's not going all the way to the end of the animation. I feel like it's missing one. Is reverse. Let's go with the -1 just to see real quick. It's like if you want to simulate like a bird flap, like you want the down and then you want the upstroke. So having a reverse option is always good. Or, you know, there's a million things where the reverse of a thing is also desirable, so. Okay, so that was wrong. Frame index ding. And we're pretty much there. Just, I feel like the coin needs to finish its movement before it reverses. We just go -1. Reverse. If you log note, if you log and whatever. Modulus d on modulus d equals modulus d, which is underscore frame index underscore frame count, and then we're taking the index. Let's just log them all. It's only 6 frames per second. It's not that bad. All right, do log. So we're going to log way more information than we need, but it's fine. Okay. So I would expect to see so 1, 2, 3, 4, 5. Agreed that it repeats. Repeat. 1, 2, 3, 4, 5. I want 0. Okay. Oh no. 5 to 5. We never hit this one. Okay. Reverse is not quite right. -1. 0 minus the index. -1. Super close. Hmm. 0, 1, 2, 3, 4, 5. 3, 2, 1, 0. 0, 1, 2, 3, 4, 5. 5, 4, 3, 2, 1, 0. It doesn't go all the way. Where's that last frame? Oh, it does though. I see, said the blind man. So in this one, we do actually want that 7th index. We do want it to go all the way around. Because then the reflect doesn't loop it. Boom. Yep, that's better. Okay. All we have to do now is clean up our logging. Sprite. Not the debug ones. That log is fine. Basically everything in ding, except for that one. Do log actually, that's probably the better thing to search for. Okay. There we go. One, two, three, 4, 5, 6. Okay, perfect. 6 flip-flops. Okay. I think we're good then. That's probably good enough for today. We got loop end times, which we will add some notes about right here. Looping support added when hitting a stop condition. Checks if it should repeat instead. If loop count is less than 1, loop forever. If otherwise, do a repeat and reset the end of sequence operation index. There we go. So we have some reasonable control over our sprites. The next thing will be to get the ImageWarehouse There's one more thing I want to add a note about, but I'm not going to work on it today. We'll work on it next week. We've got time. Okay, we want the image warehouse to say, look, there was a UV, there's a sprite animation named this. So let's see, image warehouse. We named one called spin, and we know where it starts and where it stops. So we should be able to ask the image warehouse, hey, give me the animation sequence for spin, and give me the animation sequence for idle, which both apply to this texture. And it should be able to give me this as an array without me having to construct it myself. I think that is a true statement. I think we should be able to do that. That doesn't sound hard at all. So that'll be Monday. Monday we're doing that. The other thing was this one, boolean for if the sequence is a closed loop. Don't read it, then size minus 1. So basically, the image warehouse is going to have a sequence of 0, 1, 2, 3, 4, 0. And if you say, hey, give me the animation named spin, it'll give you this array, and it'll also give you the length of the array. So if you say, hey, I know that this sequence is a closed loop, or I want to treat it as a closed loop, then it will return the size. And if you say this is not a closed loop, don't return to 0 at the end of it, all it has to do is return the size minus 1 so that you just see this much. So that is, takes up no more room, no more major calculations, don't have to reallocate anything. I think that's what we'll do next time on Monday. And then we'll basically be done with even the good parts stuff added. We'll be into, oh, we figured that one out. We figured that out. Okay. So I need to add that note. We did figure that one out. Okay. Found the issue with font store cleanup. Font cleanup was being called the font library before font store cleanup was ft done face. The only real question is how this didn't seg fault every time since the beginning, since the 2 cleanups were in place. Okay. Okay. There we go. So in our to-do, we basically have polish, clean up, make it all better. Especially for something for the practice guesses. Check. We're gonna add more polish notes, but there are things like this, like, hey, there's this thing that's ugly, let's go fix it. You know, polishing things. So we'll be adding to this polished list later, but overall, I think we are in really good shape. We have some tasks on Monday that are not polish. This is good. Okay, awesome. So we'll run end of week stats some other time. Maybe I'll run it tonight, and then we can talk about it tomorrow briefly before compiler day gets rolling. But thanks for dropping in. Thanks for all the watches. Thanks for the chats. We will see you tomorrow on compiler day. Yes, compilers. We generated a whole bunch of functions which sort of almost should do things, but we need to put that inside of a framework that loops. Heck yeah, exactly. Perfect. So thanks. We'll see you tomorrow. You have a wonderful evening. Enjoy your pizza. I'm going to go find out what I'm getting for dinner. So catch you next time.